Alright, welcome to the quick video on chlorofluorocarbons, or CFCs. Alright, so what we're going to do here is understand what they are. We know that basic hydrocarbons, let's do methane for example, is CH4, okay? And then we have the rest of the homologous series, so ethane, propane, butane, etc., right? So we have hydrocarbons, but if we replace those hydrogens with halogen atoms. Now remember, a halogen atom is from the group 7 of the periodic table, or group 17. And so in this instance with chlorofluorocarbons, we're replacing it with chlorine and fluorine atoms, right? So if I stop that from running by doing that, if we replace that central carbon and we have, let's say, 2 fluorine and 2 chlorine, then we have what's called a haloalkane, specifically looking at chlorofluorocarbons. So with that, all of the hydrogen atoms have been replaced. Okay, all of the hydrogen atoms have been replaced, and so that's what's called a CFC. Now, why were they made? Well, originally in refrigerators we had ammonia as the refrigerant gas, and ammonia, however, is toxic and it's a base. So they wanted to find a gas that was less toxic, that was not reactive, and that could be liquefied easy, right, or easier than ammonia, okay, not requiring as much pressure to liquefy it. And so they came across these CFCs. And so we had CFCs being used as refrigerant gases in fridges, but we also had them as propellants in sprays, so body sprays, paint spray, cans, etc., all had these hydrocarbons, or CFCs, as a propellant, right? However, when we did find out that these contribute a lot to the destruction of ozone, and that they lasted a long time in the air, so they're unreactive, which is great when it's down on Earth when we don't want to react with anything. However, when they go up into the stratosphere, they're unreactive, and therefore they don't disappear. They hang around for a long time. And so up in the stratosphere, where they get hit a lot more with UV radiation to form reactive radicals, they react with ozone, destroy ozone, but then they keep destroying more and more molecules of ozone. And we'll look about that in another video. But they were the bad guys, right? So when we started finding out that CFCs were one of the key molecules that caused ozone destruction, we had to try and find a replacement, okay, for them. And we're going to do a separate video on the replacement gases, right? Now, halons, well, they're also another class of haloalkanes that do damage to the ozone. And those ones, instead of having chlorine and fluorine, they have bromine and fluorine. So if we go something like this, okay, but in terms of the systematic names, that's coming from a methyl. It's got 1, 2, 3 fluorines, and it's got 1 bromo. So it would be 1 bromo, 1 trifluoromethane. Okay, so that's its systematic name. This is its common name. Okay, and this one here has 2 chlorines and 2 fluoro, so it'd be 1 dichloro, 1 difluoromethane. And we'll get into another video about how to do the systematic naming of these. So halons, well, what are they? You can see that they've got different substituent atoms. Here we've got a bromine, whereas here there's no bromines in chlorofluorocarbons. These here were made as fire extinguisher propellants. And so these are another class of haloalkanes that cause ozone destruction. And they do so to a different, what's called oxidizing potential, or ozone depleting potential, ODP, and we'll look at that in a later video, but they still contribute to the destruction of ozone. So these are 2 classes of haloalkanes which were made, one for refrigerants and propellants, and this one here was used in fire extinguishers, and both of them contribute to ozone destruction. So therefore we want to find a replacement gas that we can use for these, and therefore prolong the life of the ozone layer and prevent any further destruction. And we'll talk about more of that in another video as well. But that's a quick video on those 2 classes of compounds. You know how they're drawn, you know where they came from, and you know that they have damage to the ozone layer. Okay, that's it. Nice and quick and simple. All right, see you in the next video.